At this point, we just need a little more practice. So I'll do a couple more for you, and then at that point, you just need to do them. When I see all of this, I'm going to distribute this across, again thinking algebra, but I'm going to take this cosecant, I'm going to change that into 1 over sine, and make sure we write that correctly. Now when we distribute it across, sine times 1 over cosine will be 1 minus sine squared. And again, you want to think Pythagorean identity. So sine squared plus cosine squared is 1. So 1 minus sine squared is cosine squared. And that's it. Try to do the next one by yourself and then check the video. Hit pause. All right. 1 over sine of b minus cosine of b times cosine of b over sine b. So we're going to have 1 over sine b minus cosine squared b over sine b. So they have a common denominator. That's 1 minus cosine squared over sine, which is, again, a Pythagorean identity. Sine squared over sine. And that just gives us the sine. And that's it. Now we're going to move to proving. Yay! All right. What's the difference between a simplify and prove? For a prove problem, you already have the answer. Now, and that being said, what I want you to do is follow a specific side, a specific set of process. What we're going to do is say, first, which side looks more complicated? Now, in this case, we're going to look here and we're going to say, oh, the left side does. We have a fraction, so we'll write cotangent x minus cotangent x all over sine x cotangent x. So what we're going to do is, in this case, write that side, just like I did over here, write that side, and then put equals, and then simplify straight down until you get the final answer. All right. So what does that mean? That means we're going to write equal here. We're going to write here, we'll write all the way down until we get, we're looking for what we're trying to prove, cosecant squared minus secant squared. Now, how can we go about dealing with this? Well, one way is the way we did it before, we could treat this as, change it into all sine and cosine. Now, it doesn't have to be all sine and cosine. Before I forget, I just realized that there is a typo here. Change this. I'll change it on the video, so yours will probably already say it. This should say cosine. All right. So we have cotangent minus tangent. Let's change it all into sine and cosine. So this would be cosine over sine minus sine over cosine divided by sine x cosine x. Now what? We're going to just write the equals down. Let's simplify. Let's make this into we could combine this to a common fraction. So the common denominator here would be sine cosine. So we're going to multiply the first one by cosine over cosine. So we'll have cosine squared x, and then we'll have sine x cosine x. And then over here, we're multiplying by sine over sine. So we'll have sine squared x. And now all of this is being divided by sine x cosine x. And we can take this and multiply it by 1 over sine x cosine x. That's going to simplify to cosine squared minus sine squared over sine squared x cosine squared x. Now what? Well, we can take each one of these fractions, break the fraction up this time. Minus sine squared x over sine squared x cosine squared x. Because we know we're going to have two separate things up here. We can reduce, and we're left with 1 over sine squared x minus 1 over cosine squared x. And that is cosecant squared minus secant squared. And we have finished our proof. Ta-da! All right, let's take a look at another one. Which one looks more complicated? Well, we want to probably the left side again. It doesn't always have to be that left side. So we're going to start and we rewrite. So this first line, what we're given there, does not count for anything. Rewrite this 1 minus secant a plus 1 over 1 plus secant a. Now what are we going to do? All right, so when I see something like this, I can think, all right, what would I do when I have two fractions? I would add them together. So what am I going to do with the first fraction? I'm going to end up multiplying by 1 plus secant a over 1 plus secant a. And the other one I'll multiply by 1 minus secant a over 1 minus secant a. So what do we get? 1 plus secant a plus 1 minus secant a, all divided by, when we multiply that out, we'll get 1 minus secant squared a. Now what? That top simplifies quite nicely to just 2. What about the bottom? What do we know that has that secant squared in it? Oh, we have that Pythagorean identity which says 1 plus tan squared equals secant squared, or tan squared plus 1 equals secant squared. So we can write that here a little bit on the side. I don't have a lot of space here. 1 plus tangent squared equals secant squared. So we can say 1 minus, if it's not clear right away, and I can just substitute this in. Distribute that through, the 1's are going to go away, and we're left with 2 divided by negative tangent a, tangent squared a. So that is the reciprocal of tangent squared. So that will be negative 2 cotangent squared. Now I really haven't looked at the answer of what I'm trying to get. So there's a couple things that you could use. If you remember your proofs back in geometry, you can work backwards a little bit. If I have something like negative 2 cotangent squared, the previous line could have been what we had here, or if it was in terms of sine and cosine, it would have to say negative 2 cosine squared over sine squared. So you can use that idea, and you're looking to see, this is what I want to get. Let's try the next one. We'll take, so tan squared over 1 plus tan squared equals what? What can we do here? Well, we see we have an identity for 1 plus tan squared, the one we just reviewed. That is secant squared. And this is, tangent squared would be sine squared over cosine squared. Okay, times what? Times the reciprocal of secant squared. Well, what is the reciprocal of secant squared? The reciprocal of secant squared would be cosine squared. And that gives us sine squared, and we're done. So when you're looking at this, maybe this step here was a little too fast. We could have said times 1 over secant squared, and on the next line you could have changed that into cosine squared. But either way, you'll come to sine squared. All right, I'm going to do one more for you. And then what I want you to do is number 7. All right, so I think we're going to start on the left side once again here. So what can we do here? Again, look at that. We have two fractions. Let's add them together. What are we going to multiply the first one by? We'd have to multiply by tan over tan, and the second one, 1 plus secant over 1 plus secant. So this gives us tan squared plus 1 plus secant x squared, all divided by tangent x 1 plus secant x. Now on the bottom, you typically don't want to multiply that stuff out, just in case something can reduce out above. Now I'm going to move this over here so you have enough room to do number 7. Put equals. Let's multiply this top part out. So we'll have tan squared x plus 1 plus 2 secant x plus secant squared x over tan x 1 plus secant x. Now what do you notice? That somehow we need to simplify this. Somehow we're going to end up with just 2 cosecant, or 2 over sine. Somehow a lot of this stuff's going to go away. Look at the top. Do you notice any identity in the top? Look at this. If we group this part together, 1 plus tan squared, what does that equal? That equals secant squared. So I have secant squared plus 2 secant x plus secant squared x divided by tangent x 1 plus secant x. Now we could see, hey, let's combine those two things together. So we have 2 secant squared. The rest of this follows algebra pretty well. What can I do on that top? I can factor out a 2 secant x. And I have secant x plus 1 over tangent x, and then 1 plus secant x. And you know you can reduce those out because 1 plus secant is the same as secant plus 1. So now we have 2 times secant over tangent. So that would be 2 times 1 over cosine. I didn't leave myself quite enough room here. And I'm going to be multiplying by the reciprocal of tangent, which will be cosine over sine. So I'm going to be left with 2 over sine, and that gives us 2 cosecant, and we're done. When you're looking at number 7, look at that. Can you get any identity in there? So we'll start with the left side. Show that to me tomorrow, and then we can talk about it.